Hi everyone, in this video we are going to discuss about digital signatures. So digital signatures are basically equivalent to handwritten signatures. Like here I have shown some documents. So let's say there is some document. If I write something and after that if I'm going to put some signature there. So it means now I'm taking the authorship of the contents of this document. So that is the authorship of the contents of a document, and this digital signature in a digital world are used to check the authenticity and integrity of any digital message or digital document or software. So in that case, we take responsibility of, let's say, of that document. And this digital signatures can also help in establishing non-repudiation. So non-repudiation means a sender cannot deny the validity of the document, or the sender cannot deny having sent some email or some document. So like a sender sends some document, and if there is a digital signature, then in that case the sender cannot deny that I have sent that document, because we will have a signed document from the sender. And now for explanation purpose, we have these two users. One is Bob and second is Alice. And in this case, Bob wants to send a message, but Bob wants a strategy for Alice to verify the integrity and authenticity of the message. So let's say Bob wants to send some message, but Bob wants some strategy by which Alice can verify that the document has not been changed. And Bob also wants to have a strategy that Alice can verify that this message is really coming from Bob. And now for that, Bob will be using this public key encryption, which we explained in our previous video. And for this public key encryption or asymmetric key encryption, Bob generates two keys. One key is known as public key, second key is known as private key. And after generating these two keys, Bob can send, or Bob can actually generate a message or create a message which Bob wants to send to Alice. And once that message is created, Bob can use that message as an input to a hash function. And one important thing, that the message length can be any length, like this can be audio file or some document or some exe file. So length can have, I mean, input can have any length, the message can have any length, sorry. So this message is used as an input to the hash algorithm, and hash algorithm generates a hash value that is also known as message digest. And after creating this message digest, which will be actually of a fixed length, so after creating this message digest, Bob's private key will be used to create actually the digital signature. So here, see, the Bob's private key is used here in the input of this some asymmetric cryptographic algorithm, and then this creates a digital signature. And this digital signature, in some literature, this is also referred to as encrypted message digest. So we have this message digest, we encrypt it using private key of Bob, and then the result is encrypted message digest or digital signature. After this steps, Bob will be sending the message and the encrypted message digest and also his public key. So these three components will be sent to Alice as a signed document. And then when Alice receives this signed document, so Alice will decrypt that digital signature, which is like this. She received this one. So decrypt it using the public key of Bob, which she received in the message, or which she received in the signed document. And then she received the decrypted message digest. So this is first step, or the first thing she needs to do. So with this, she is verifying that the message which has been received, that actually has been sent by Bob, because she is able to decrypt the digital signature, or she is going to decrypt the encrypted digest sent from Bob, and Bob has used his private key to encrypt it. And if Alice is able to decrypt those contents using the public key of Bob, it means this message was really being sent by Bob. Because remember, we have learned in our previous video that if Bob is going to encrypt some message with the with his private key, then only his public key can be used to decrypt that message. There's no other way to decrypt it. So with this, Alice has actually decrypted the message digest. And the second thing which Alice will be doing is that now to verify the integrity of the message, Alice will be taking the message which she received from the signed document you received. In the signed document, we have the message. We also have the digital signature. So she takes message, and from that message, she also uses the hash algorithm and generates a message digest. So now at Alice end, she has two message digests. One message digest she has decrypted from the digital signature. So this is one message digest, and second message digest she is calculating from the message itself. Now she has two message digests, and then she compares these two message digests. And if these two message digests are equal, like here, if they are both of them are equal, then she can verify that the message was really sent by Bob. This is one thing. And the second thing is that the message has not been intercepted with, or maybe the message has not been tampered with during its transmission from Bob to Alice. So in this way, Alice is not only able to verify the authenticity of the sender, but Alice also is able to verify the integrity of the message. So this is how we use digital signature. One last point which I want to mention here is that, so in this explanation we have shown that this signed document which is sent from Bob to Alice actually contains a public key, this one. But this may also happen that they might have shared this public key before sending this document, or there can be a common server from where they can retrieve the public key of each other. So in that case, maybe we will not be sending this public key in the document itself. So this is the end for today's discussion on digital signature. Hope to see you in some other video.